Okay, number 9. Let G be a group of order 15. Prove that any proper subgroup of G is cyclic. Okay, so I want to mention some people were whipping out something called the Silo theorems or the Silo theorems for this question. I just want to clarify that theorems that are not part of the class are not likely to be the way to go. And theorems that are not part of the class, it is very hard to use them in a way that conveys information like a proof should. So don't use theorems that are outside of this class, please. This can be done with again, Lagrange's theorem only, and actually the conclusion from the previous problem. So let G be a group of order 15. So 15, by the way, right? What? Here's a question we should ask. Give this a second. Just having a seizure. Here we go. What divides 15? Well, here's some things that divide 15. Of course, you got 1 and 15. You always have those. And you've also got 3 and 5. And in fact, that's all of them. Those are all the numbers which divide 15. So if you have a subgroup, so if H divides G, is a subgroup of G, then the order of H has got to be one of those things. Now, they specifically said about proper subgroups. They specifically asked us about proper subgroups. So I should say, since H is proper, I'm a fan of that notation. We actually know that H is smaller than 15. Now let's consider those 3 possibilities, right? Say H is of size 1. Well, then H is just the trivial subgroup, and so if H is of size 1, then H is the trivial subgroup. And of course that is cyclic. It's generated by itself, so that is cyclic indeed. What about the case when H is of size 3? Well, you might say, well, okay, I don't know much about it then. Is that cyclic? I don't know. But remember what we just found in question 8. We just found in question 8 that if the order of a group is prime, like this is here, there you go, like this one is here, then it's got to be cyclic. So there you go. So this is definitely cyclic. Okay, this is a problem that this is happening here. What is the issue? Are you working? I guess so. Okay, so it's cyclic in this case, it's cyclic in this case, and then the point is, I'll get to the point here, that it's cyclic in the last case too, because the last case is that it's of order 5. Right, so we don't know that G is cyclic. We threw out the case where G is of order 15. There are many groups of order 15, like Z15, and also Z3 cross Z5, which is different from Z, not isomorphic to Z cross to Z15, and it's not cyclic either, is the thing. Or wait, no, it is. Wait a second. Sorry, I'm wrong. Those are isomorphic because they're coprime. Oh, okay. But there might be other groups of size 15, which are not cyclic. But even then, their individual subgroups are indeed cyclic. They're proper subgroups, because their proper subgroups are either trivial or they're of prime order, which we know makes them cyclic by question number 8.